All right, so let's begin. Oh, I forgot. We still have this. Let me pause this. All right, so let's look at what our big idea was yesterday. Our big idea was that once we get to here, so we had 4 over 2, which is 2, I already know, and 8 over 4, which is 2. But if I wanted to make them look the same, we discovered that our numerators would be equivalent as well. As long as our denominators matched, our numerators match too. And everybody's attention up here. Gosh. Okay. So let's keep going. What if we had a variable in there? Well, we did the same process. We multiplied the numerator and the denominator by the same thing, or 1, to make it more complicated so we can make the denominators match. So we can apply that same principle here. If 4 is equal to 4, then 4x must be equal to 8. And that's what we're going to use today. All right, so we're going to finish solving our rational equations today using those common denominators. But I'm going to start here. Yeah, I'm going to start here. Let's take a picture of this. All right, I just need a little bit more space. All right, so I'm going to solve for this one. It seems to be in front. Bring. So I say to myself, can I factor anything out of x minus 4? I can't. It's just x minus 4. 1 over x minus 4. If nothing can be factored out of it, it's a quantity, right? It's an actual number. I may not know what x is, but as soon as I figure out what x is, this is just one number, okay? It's just a number that's smaller by 4. So we're going to put that together. It's on lockdown. It's a factor. It's its own factor. Just like 12 has 2 factors, more than 2 factors, but I could say 12 is 3 times 4, right? This doesn't have 2 factors. It's 1 factor. All right. So plus 2 over a factor of 1, because there's nothing there, equals 3 over a factor of 1. So I'm going to ask myself what my LCM is. Well, this breaks down to the only factor here is x minus 4. The only factor here is 1. And the only factor here is 1. But if I take x minus 4 and multiply it by 1, I get x minus 4. And x minus 4 by 1 again is still x minus 4. So my only least common multiple is x minus 4. I go back and I ask myself, what do I need to do to x minus 4 to get me x minus 4? Nothing. It's already there. So I have 1 over the quantity x minus 4. Then I ask myself, what do I need to do to 1 in order to have an x minus 4? And then I multiply it by x minus 4. And I'm not changing it because if I multiply it by a numerator and a denominator the same, I'm actually just multiplying it by 1. Equals 3 over 1. What does that 1 need? An x minus 4. Now I know this is read from yesterday, but I think some of you need to see it again. All right, because then it'll be simple. You'll say, gosh, that was a lot easier than I thought it was. All right, so now I'm going to multiply straight across to make sure that I have common denominators. But I'm not going to multiply my factors. I'm just going to keep them as factors. So I have a 1 over x minus 4 plus I have a 2 times x minus 4 all over x minus 4 equals, and then I have a 3 times x minus 4 all over x minus 4. Now that they're all the same, I can combine like terms, right? I can combine like terms right here. Since x minus 4 and x minus 4 are the same, I can combine whatever's up here. Let's stop for a second and go back to 6th grade math. I think 6th grade math, I'm not sure. Let's look. So one, I want to add one, okay? I want to add both of those, and I want it to be equal to something over 60. All right, I'm just going to even ignore this. I don't even want to see this. I'm just going to look at this. In fact, we're just going to ignore it. All right, so the factors that I have here, if I'm saying, I don't want a huge number. Some of you will remember from elementary school, you multiply 12 times 15, right? Multiply this one by 15, this one by 12. That makes a huge number. It works, but it's not the least common multiple. It's the greatest common multiple, right? So if I just want an LCM, which I want it to be in a different color, if I just want the least, I start looking at factors. I say to myself, I know that these two have a common factor. They both have a 3. This one is a 4 times 3. This one is a 4 times 3. And this one is a 3 times 5. So when I go to get my least common multiple, I have to find multiples that they all have in common. So this one has a 4 and a 3. This one also has a 3, so I don't need that one, right? And it has a 5. So then I ask myself, what do each one of these need? This one has a 4 and a 3, so we need a 5. And this one has a 3 and a 5, so it needs a 4. So now, if I multiply across, I have 5 times 1 is 5 over 5 times 4 times 3. And this one is 4 over, I'm just going to switch some things around, 5 times 4 times 3. Now that they're the same, I can add the numerators. I have 9 over 5 times 4 times 3. That's all we're doing here, right? We're getting common denominators so that we can add the numerators. Only in 6th grade, you didn't write it like this. You actually multiplied it out and made it 60. So it's the same math, right? It's the exact same process. We're just dealing with, we're breaking numbers down and dealing with factors now instead of multiplying it all out. All right, so let's finish this. So if I were to combine these, so since this is over x minus 4 and this is over x minus 4, I can say I have 1 plus 2x minus 8 all over x minus 4 equals 3x minus 12 all over x minus 4. Quantity x minus 4. Now what I showed you yesterday mathematically, this is where this starts to change. When I showed you mathematically is once I get to this point, right, I could actually multiply by the reciprocal, and all of a sudden I no longer have denominators. And I'm left with 1 plus 2x minus 8 equals 3x minus 12. But check this out. Couldn't I have done that right there? It's the same. 1 plus 2 times x is 2x minus 8. It's the same exact thing. So I just cut out a huge step by knowing that if all my denominators are the same, then all my numerators, I can just concentrate on those. That's all I need. Okay, it just takes that step right out. So now this is a real easy Algebra 1 problem, right? I've got a 1 and a negative 8 makes negative 7. 2x minus 7 equals 3x minus 12. I want to move the 2x, which gives me negative 7 equals x minus 12. Then add my 12. I wish I had made it prettier. But I'm going fast because you guys all know this math. 5. Okay. What does this mean? What does x equal 5 mean? Okay, if I put 5 back in the equation, I'll get an equivalent equation. You're right. That doesn't have a lot of meaning for me, though. All I have to do is make sure my excluded value is 4, so I'm okay. So you guys are telling me that x equals 5, correct? Let's go back to our graph. You're not going to have to do this, but I'm just going to tie it in, okay? All right, going back to my graph. If I have 1 over x minus 4 plus 2 equals 3, I could split these two up over here. F of x equals 1 over x minus 4 plus 2, and g of x equals 3. Remember doing that with absolute value equations? Right? We'd take whatever was on each side of the equation, and we would set them equal to each other, and then we would find their intersection point, and that would be our solution. That's what we're going to do really quick. Okay, so I know how to graph this. Gx equals 3. Let's use different colors. Gx equals 3. We usually do that in red, right? Go up 3. This one is going to be shifted over 4. What do we do, our asymptotes in green? It's going to be shifted over 4 because x cannot be 4. So I'm going to go over 4. 1, 2, 3, 4. There's one asymptote. Other asymptotes at positive 2. So I'm going to go up 2. 1, 2. Awesome. So then I'm going to graph it. It has a scale factor of 1. So I'm going to go over 1, up 1. What did I just find? I just found an intersection. Amazingly enough, that intersection is at five on the x-axis. Matches. Okay? Now, if I were to do it, set this whole thing equal to 0 by moving the 3 over, then it would actually intersect on the x-axis. Okay, so that's just a side note. That was kind of like a, hey, it's kind of cool they match, but more of it was just, hey, let's review our graphing rational expressions again. Okay, that was kind of the purpose of that. All right, so I'm going to move on to what you guys were supposed to do last night. So last night, I'm going to argue that we're going to cross these two out right here. You don't need to combine like terms and clear denominators. Once you get common denominators, question mark plus happy heart equals happy face. Once we have common denominators, I know that question mark plus heart equals a happy face, right? They all have the same denominator, so I don't even have to worry about it anymore. So the big work is getting the same denominator. Then the easy work is what we're going to do today. Secondly, you've got to worry about whether or not when we get here, if it's going to be linear, we solve it like Algebra 1. If it's going to be quadratic with an x squared, it's going to be more like Algebra 2. And that's what I'm going to do right now with you. Okay, so this was dreaded number 3, right? Oh no, 3 was easy. That one was the one you guys didn't like. right? It's really not, it's just a lot of stuff, right? Okay, let's look at this one first. So if I look at this one first, from what I just told you, I have matching denominators, right? So don't I just this is a subtraction sign? Isn't this all I need? Do I really need to do that with you? I don't think I need to do that with you. Right? You guys know how to solve 27 minus 10x equals negative 13, right? You solve for x. So I'm not going to spend my time doing that one. What about this one? All right. Everybody matches? Fantastic. So if everybody matches, oh, that's going to be too much. If everybody matches, still too much. I have to rewrite it. Oh, well. There we go. Everybody matches, so I'm just going to take my numerator. Since I'm just going to rewrite it. 15 times x plus 4 minus x plus, this is messy. Why am I being so messy right now? 15 times x plus 4 minus x plus 3 times x plus 4 equals 12 times x plus 3. We should all be able to do this. It's really not that scary. It's just scary with all of it put together. Right? When you have to do all this and then they go, okay, now let's start. Right? I think that's why you guys got overwhelmed. They're not really that hard. It just takes a lot of room on your page. You just have to make sure that you don't skip steps and make sure you're consistent. But other than that, it's not very different, right, than 6th grade math. It's the same thing. You just have variables. All right. I should say the process is the same. Try that again. Okay. So I'm going to distribute first. So 15 distributed is 15x. 15x plus 60. I don't want to deal with a subtraction sign right now, right? I don't want to distribute that because I got some foiling to do. It's kind of ironic. What did we start doing in the very beginning of this problem? Foiling. And what do we have? No, not foiling. Factoring, right? And then at the end, we got to foil. So we got to undo what we started with. You're repeating a process in reverse. Okay. So, Sydney, sit up. Okay. All right. So, x times x is x squared. 3 times 4 is 12, right? That was how we broke up 3 and 4 was with 12. But then I had to make sure that I had 3 x's plus 4 x's makes 7 x's. If you can't do that in your head, you need to use a box, right? And you guys should all know whether or not you can do that in your head by now. It's easier if you can get there because then it's less work. 12 times x plus 3. Distribute that 12. I don't think it caught on. Oh, yes, it is 12x plus 36. Yep. On the 15. Thank you. All right. I can already see a problem. I can already see that this and make x squared negative. So you can pick 2 different ways you guys want to do it. You can either distribute the negative to everybody and move the x squared, or we could just move the whole thing over there and it'll be positive. Which would you rather do? Just move the x squared? Okay. I can deal. So